repair to me, I'm a sustainability guy. I like to say that I engineer concrete solutions for the next generation of sustainable infrastructure. And repair is so integral to that, because if we can repair the infrastructure we have, if we can retrofit it to be more resilient and more sustainable, then we don't have to rebuild it. Hi, everyone. Welcome to the ACI Engineering Greatness Podcast, a podcast for young professionals by young professionals. I'm Robert Thomas, assistant professor at Clarkson University in Northern New York, and I'm here today with my co-host, Jovan.
Hello, everyone. My name is Jovan Tatar. I'm an associate professor at the University of Delaware. Thank you for joining us. Right, Robert, so how did you end up choosing civil engineering as a profession?
I've always been pretty fascinated with how the world works. I was the type of kid who was constantly taking stuff apart. My parents were always very annoyed by this, but I was constantly taking stuff apart to see what was inside. Like, I've always had this desire to understand how things work. So when I was going to college, I knew I wanted to be an engineer, but to be honest with you, I didn't really know what that meant for me. And I was kind of always evenly split between civil and mechanical. I wanted to either build bridges or build machines, but I wasn't quite sure which. So when I got to college in the fall of 2011, I was, engineering studies or undeclared engineering. But, I found a good community within the civil engineering department at my college. I found an academic advisor that I kind of resonated with, and I kind of liked the courses that they had us taking. So around the beginning of my sophomore year, I kind of took a leap of faith and said, I'm going to declare civil. And, the rest is history. So how about yourself? How'd you end up in civil engineering?
Cool. Kind of a similar story, I guess a little bit different. So I'm originally from Montenegro. And when I was finishing high school, I was really good in math, physics, sciences in general, really always been interested, in understanding how things work. So I knew it was going to be engineering. And then when it came down to picking the exact, engineering discipline, my dad was like, construction industry is booming here right now. There's a lot of tourism. There's a lot of development. So I was like, okay, civil engineering sounds good to me. And eventually that's how I ended up in civil engineering. What led you to focus on concrete?
It's actually really interesting. I've always found concrete just incredibly fascinating. A lot of people don't realize the original patent for Portland cement, that 1824 Aspidin patent, he called it something like, a process for making artificial stone. And to me, there's no more quintessential civil engineering challenge than taking what we know about chemistry and physics and replicating these geological materials, but in a form that we can use to build infrastructure. Concrete is the fundamental building block of all the structures that keep society functioning. And that's just incredibly fascinating to me. And when I was a kid, I used to work, we had a family friend who was a mason. So sometimes I get to work with him doing, some sidewalks or some slabs and things like that. And I loved that kind of work. But, I honestly didn't realize that I could make a career out of concrete until my senior year of college. I took this class called Properties and Performance of Concrete. And it kind of blew my mind when I realized that there are people out there who make a living just studying concrete and trying to learn more and more about it. And that class honestly changed my life. And I still find concrete incredibly fascinating. I still find myself really fortunate to be able to work in this industry. So what is it about concrete that gets you going?
So let me give you some background. Basically, my third year of college, I was at the University of Wyoming as an exchange student, and that's where I met Charlie Dolan. He's a longtime ACI member, really great structural guy. He did a lot of cool work in repair of concrete structures and work with composites. So when I came to the University of Wyoming, I was completely lost, in a different country, different university. Everything was new to me. And he was assigned to me as an advisor. So I sat down with him, we talked, I signed up for his class. ended up taking his reinforced concrete design class. He then told me he was doing some research with composites and concrete. And so I was like, okay, cool. Like let me try this out and see if I can learn something interesting here. And that's where I really fell in love with, concrete. I worked with him for a semester, publishing a paper, ended up learning a lot, it was just exciting to me to build something and then break it and then look at the data, analyze it, learn something new that perhaps nobody else learned before. And so here I am.
Yeah, that's great. I feel like I resonate with that a lot. So how'd you get from there to being an academic, right? How do you go from your love of concrete to being a professor?
Yeah, so when I was done working with Charlie, I ended up going back home, finishing my bachelor's. And Charlie recommended a few programs in the US. So I ended up applying to those, one of them being University of Florida, where I worked with Trey Hamilton. I first came in as a master's student because I wasn't sure if I wanted to stay in academia, if I'm actually going to love research as much as I thought I would. So I, again, ended up falling in love with my project. It was a kind of a continuation of the project that I did with Charlie. So I continued to work with composites.
Okay.
And so I stayed for a PhD and eventually finished my PhD and ended up getting my first academic job right out of my PhD. What about you?
So, I never intended to be an academic. It was nowhere near, it wasn't even on my radar. Right. So I'm a senior in college and I'm going to career fairs and trying to get jobs and things like that. And I had declared structural engineering as a concentration. And so I thought I was just going to go be a structural engineer and get this design job. And, I had this job offer. I was going to be working for the naval shipyard doing some type of structural design. And the more I thought about it, the more boring it sounded, to be honest with you, because I had gotten to love being in school, and I was looking at these professors who were teaching these classes I was taking. I was looking at the research they were doing and just, decided again to take a little bit of a leap of faith. And there was a professor of mine who had a project who was looking for some students. I figured, hey, I'm already here. It might be an easy gig to get. And so I went and talked to somebody and found myself a master's degree and my mentor, my advisor at the time said, hey, there's another project. Why don't you stick around and get a PhD and see how that suits you? And here we are, 10 years later, still in academia. And I got to be honest with you, I love it. There's that old saying that we as academics, we learn more and more about less and less until we know everything about nothing. But concrete isn't nothing, right? Concrete is everything and it's everywhere. And it's, like I said before, it's the fundamental building block of society. So it's like for me, being a professor versus, say, being in practice, being a design engineer, it allows me to participate in the generation of new knowledge that can kind of transform the industry in a very real way.
I totally relate with that. I remember, when I was nearing the end of my master's, I ended up talking to one of the senior PhD students in Trey's in our research group. And so, he got his master's, he ended up coming back for a PhD several years later. And I was like, why did you come back to get a PhD? And he told me, in industry, things get repetitive. You're learning a lot initially, but then eventually you get to a point where you pretty much know it all and it becomes pretty repetitive, or you end up being a manager. And to me, that just didn't sound like something that I would want to do. And just like you, with being an academic, I just feel like we're constantly learning, we're constantly growing. Not saying that that's not the case in industry, but I definitely think that we tend to, stay more technically involved, which I ultimately, liked about engineering.
Yeah, I totally agree. So you mentioned a couple of mentors that you've had, Dolan. Did you say Dolan?
Dolan, yeah, Charlie.
Yeah.
Dolan.
And so so how, like are there particular people that have really influenced your career trajectory, or how do you go about finding those people? How do you go about like picking the person that you did your PhD with, for example?
That was kind of like a linear trajectory, really. So
Mm.
I worked with Charlie first. He knew Trey Hamilton at the University of Florida because Trey actually worked at the University of Wyoming. That was his, I believe, first academic job.
Okay.
So, you know, Charlie recommended me to Trey. Trey ended up offering me an assistantship, and so I ended up there. I trusted that, if Charlie thought that Trey would be a good mentor, I trusted that Trey was actually going to be a good mentor. And, that turned out to be, I would say, one of the best decisions, because becoming a faculty, it's not just about, developing your technical skills, which is, I think, a lot of PhD students will develop those inevitably. But I think it's about also getting some professional development opportunities and being guided through the application process for a faculty job. I
Yeah.
think that's what definitely differentiates those who are successful on the academic job market versus those who may not be as successful.
Yeah, I completely agree. Completely.
Who were your mentors? How did you end up choosing them?
Yeah, I got my master's and my PhD at the same school at Clarkson University, which is where I teach now, but also where I did my bachelor's. I had a little bit of a break between my role as a student and my role as a faculty member, but my master's and PhD advisor was Sulafa Pithamparan, and she was a young assistant professor when I was getting ready to start grad school, and to be honest with you, I wasn't the best undergraduate student. I had like a high B average, and I wasn't particularly motivated or a particularly impressive candidate. And she had this project, and I saw about it in the university news brief, and I was thinking at that time, hey, I might want to go to grad school. Let's see what that's all about. And she took a chance on me, and I took a chance on her, in the sense that I wasn't sure about grad school really, but I was going to give it a shot. It's one of those things that really worked out, which is why when it came time to finish my master's and start a PhD, I signed up without even a hesitation, because she was so impactful in my career, because she took like a curiosity that I had and turned it into really a passion. She gave me a way to focus that curiosity into actually doing something with it, instead of just floundering around and kind of wondering. And I'm so thankful for that in hindsight. She still, even more than 10 years later, she's still one of my greatest mentors, and I still go to her for advice all the time, really. So, as I think there's a misconception, and we've talked about this before, but I think there's a misconception about professors, that all they do is teach, right? Do you want to talk about that at all?
Yeah, I think we face this a lot. Yeah, the first question that you usually get asked as a faculty is like, what do you teach?
Mhm.
And it's true that some faculty only teach or mostly teach, but for the majority of faculty in, say, majority of schools, they do some combination of research, teaching, and service. I think in case of our schools, we are mostly focused on research. For me, uh, research is about 70% of my workload.
Mhm.
So I get to teach only 2 classes each year. And I think that's something that's important for, those who are considering academia in the future to really uh, think about what they want to do in academia. Do you want to be mainly focused on research like we are, or do you want to, pick a route that's maybe a little bit different and you're focusing on teaching primarily, or maybe you want to do some combination of teaching and service? What are your thoughts on this?
Well, I completely agree with you. And to be honest with you, that has been in my, I just finished my, I guess, fourth year as a faculty member. That's been my number one challenge, is figuring out how to balance all those roles, right? You've got to teach, you've got to do research, you've got to do service. You're a scholar, you're a teacher, you're a member of this academic community, this campus environment, and you've got to somehow figure out how to balance all your energy. Like, where are you going to put your energy to? And not only do you have to figure that out, but it's a fluid thing, right? So sometimes you're putting all your energy into teaching, and sometimes you're not thinking about teaching at all. And you have to know what's appropriate. And of course, we all want to be great researchers, because let's face it, for schools like the ones we're at, our tenure package depends almost entirely on our research portfolio. But at the same time, I think we have a responsibility as professors to try to develop and train really good engineers. So you can't ignore that part of your job. You still have to be an excellent teacher. But when it's only, you said 70% is research, mine's supposed to be about 60%, but pretty close. You have to figure out how to make that work, but still tick off all those boxes that you're expected to tick off.
So how do you do it?
You take it day by day. you have to get really good. And this is one of those things that I don't think we're trained for. I think we spend our PhDs learning how to be really good researchers, but we're not trained for things like project management. And we don't always have to think about what's our priority for right now, what's the critical path for today. And I think it's a little bit of learning on the job.
Connect with thousands of the concrete industry's brightest minds at the ACI Concrete Convention. Held each spring and fall, the ACI Concrete Convention is the world's gathering place for advancing concrete materials, design, construction, and repair, bringing together the world's most well-known leaders with professionals looking to learn. With more than 40 hours of technical and educational sessions, professionals can take their concrete knowledge to the next level. Want to get involved in developing the latest concrete codes, specifications, reports, and programs? Stop by an ACI committee meeting or join any one of ACI's 400-plus committees. Looking to compete in a hands-on concrete competition against other students from around the world? Recruit a few of your classmates and form a team to compete in the student competition. Need to grow your lead database or connect with potential suppliers and customers? Sign up to be an exhibitor or sponsor. With a convenient and central location, the exhibit hall is the perfect spot to catch up on the latest industry products and technology, or establish a new business connection. Wind down your evenings and celebrate concrete design and construction excellence at any one of ACI's receptions or mixer events throughout the week. Whether you're a long-time returning attendee, showcasing your latest products, competing in the student competition, or attending your first ACI committee meeting or convention, join your fellow concrete enthusiasts at the world's gathering place for advancing concrete. Explore today at aciconvention.org.
What is the biggest challenge that you face?
I think that's it. It's balance, it's time management, it's knowing what the right thing to do is at the particular time. How about you?
Well, I would say that, working with grad students, managing a research group is definitely something that I struggle with the most, because I think and the way I approached it initially was, Trey Hamilton, my PhD advisor, did certain things a certain way, and I was like, let me do the same. And I realized, that doesn't work. So, and we are really not trained to do these things, like you pointed out. We are not trained to, we are trained to do research, but we're not trained to really manage a group of researchers, or trained to mentor a senior, a PhD student, or even a master's student. So I think that was definitely the biggest challenge for me. And I would say, initially I was learning how to do this on a trial and error basis. Now I'm starting to be more intentional about it. So I'm starting to sign up for different workshops and some more like formal opportunities, educational opportunities to grow in this area. But it still remains, I would say, one of the biggest challenges.
Yeah. So how about this? We talked about a bunch of different roles that we have. We're researchers, we're managers, as you just pointed out, we're teachers. Like, how much of your week do you put towards each of those roles? Like, how long in the week are you wearing each hat?
It really depends. It depends, what's happening. I would say initially when I started out as a faculty, I was definitely putting in more time into teaching than I think I should have. Now that I have, research funding, many grad students that I'm working with, I think I'm putting in way less time into teaching than research. Of course, that really depends on the week. If I've taught a class or even a semester, if I've taught a class 3, 4, 5 times by now, I don't need to prepare too much for teaching. So teaching is really starting to become like less, it requires less of my attention and time. If I'm asked to teach a new class, well, then teaching definitely takes over and I have way less time to devote to research. So I would say it really depends on the circumstances. How do you work around this?
Yeah, I totally agree with everything you said. So let's take the semester, right? Today it's approaching the end of August. Semester's about to start, and so I have, this week I've devoted to course prep. But the 10 weeks prior to this, that time was from when I put my final grades in the spring to about a week ago. I was 100% focused on research, and so the grad students are in the lab over the summer. They're getting a lot of work done. I'm meeting with most of them once at least, if not twice a week. I'm going to campus, and actually, I love the summers because I actually get to spend time in the lab, and I actually get to get my hands dirty. But then during the semester, you have office hours, you have undergraduate advising, you've got, service committee meetings, and so I may be devoting 3 days a week to that stuff, with teaching. And so I may only get 2 days a week to actually focus on research. And I may not set foot in the lab except for when a student has an issue that they need me to look at. So it really does depend a lot on the time of year. I think you're right about that.
I would also say, one thing I miss right now is initially I used to spend a lot of time in the lab with the students. I was very involved with the research projects. I got to a point where I just don't have that time or give to be in the lab. So I think one of the challenges that I've been facing as of lately is trying to stay aware of what my students are doing and really be able to provide adequate advice with the limited amount of information that I have in front of me when I meet with the students.
Sure. That reminds me of something I did through ACI. They had me do the Emerging Leaders Conference a couple years back, and one of the things I remember from that, it's been several years, but one of the things that I took away from that is that when you become a manager, your primary value add to the situation is no longer technical; it's as a leader. And that was really hard for me because I love being in the lab. I love getting my hands dirty, but you have to take a step back when you become a faculty member. You have to realize that if you want to be able to do any work, you've got to get funding. And so you have to be writing proposals, and your grad students are the ones with the boots on the ground, but somebody needs to manage them. Somebody needs to lead them and mentor them and train them and prepare them, for their future roles. And so your involvement in the situation really changes form.
Yeah, I totally agree with that. Let's maybe rewind a little bit and maybe talk about our journey into the academia a little bit more and kind of like through the academia, I guess.
Sure.
After the PhD. How did you end up at Clarkson?
So, I went to Clarkson, as I mentioned before. I went to Clarkson and got all 3 of my degrees there, and I did that not because I thought it was a great idea, but because it was an environment where I, felt supported and where I felt like I could succeed. It was just a small school, highly research intensive, and so I really loved it there. I had an advisor that was great, but I knew I wanted to be a faculty member. I got a lot of experience teaching as a grad student. But I also knew that if I wanted to be a faculty member, I needed to go somewhere else. I needed to get some experience outside of that Clarkson community. And so I started looking for a postdoc, and I was looking around, and there was all sorts of positions available. And I wasn't exactly sure what I wanted to work in. My PhD was on alkali activated materials. So really sustainability focused and alternative cements and things like that. So I also wanted to broaden my expertise a little bit. So I found I found a postdoc advisor and a postdoc position at Idaho State University. And we were going to be studying the basically the blast resistance of ultra high performance concrete, a project that was funded by the Defense Intelligence Agency. And that really piqued my interest because it was something totally different than what I'd done before, but it was still really materials focused. So I went and did that postdoc, found it really rewarding. It was just an absolutely great opportunity. Took me out of my comfort zone for sure. But my postdoc advisor changed jobs. He moved from Idaho State University about 100 miles south to Utah State University. And so when that appointment was up, I followed him down to Utah State University. And at that point, I kind of started to understand what I was doing. I was comfortable with a lot of different topics. And so instead of just having one project, he put me on about 7. And, I started getting a lot of experience writing proposals and project reports for various agencies and experience mentoring grad students and supervising undergraduate researchers and things like that. And, at this point, I finally felt ready. I finally decided that, okay, I've got the broad experience that I think is really going to help me get a faculty job. And so I started looking around, applied for really, let's face it, hundreds of jobs. You know how the academic job market is. There's more people than there are jobs sometimes. So I was applying to all these jobs and going on some interviews and trying to find a program that was a good fit for me. And somebody emailed me this posting from Clarkson one day. And I said, hey, I know that school. It turned out they were looking for somebody just like me. They were looking for somebody who had experience doing experiments, somebody kind of sustainability focused. And, so after convincing my wife that we could move back to the cold upstate New York region, I applied and the rest is history, I guess. So you were telling me one time that you didn't do a postdoc. You went right from your PhD to a faculty position, right? How did that work?
Yeah, so I was, I applied to a few postdocs, and then I also applied to some faculty jobs. And in the end, I, had an offer for a job at the University of Louisiana at Lafayette, tenure track assistant professor job. And I just couldn't turn that down for a postdoc. And the reason why I did that was because, this was a smaller school. I knew I wanted to do research, and this place had a pretty good research infrastructure for me, coming right out of school. I wanted to get experience teaching. I wanted to get experience managing a research group, writing grant proposals, kind of like everything that you do as a faculty member. And so I spent 2 years there. I realized I really enjoy what I'm doing, but one thing that I kind of wanted for my career was to be in a place that is more research active. And so I ended up applying to a few schools in the second year at the University of Louisiana. Ended up getting an interview at Delaware. It turned out to be a great fit. There was several faculty there who did research in a similar area to mine, where I felt like I could collaborate with them. They had a great Center for Composite Materials, which also was aligned with my kind of research interests. So that's how I ended up coming to Delaware. And, in hindsight, I'm happy with how everything worked out, because I feel like if I came to a school that's bigger and more research active up front, I think I would be lost a little bit, because I really didn't know what I was doing the first year, even in Louisiana. But coming to Delaware after 2 years in Louisiana, I think that really prepared me to start submitting proposals immediately. I had a few classes prepared, so I immediately knew what to teach, so I could focus more on developing my research program. So yeah, I've been at UD for 4 years now, a little bit over 4 years. I just recently got tenure. Was promoted.
That's great.
So yeah, thank you. So yeah, here I am.
Yeah, I think you make a really good point about, like, there's so many things. So you finish your PhD and then you want to go into a faculty position, but there's so many things you don't know. You might not know how to write a grant, right? You might not know how to do a budget. And sometimes people ask, like, what do you wish you knew before you got this job? And my answer is always, I wish I knew what I didn't know, because there's so much of it. There's so many things that you may not realize are part of the job. You may think are trivial until you actually start to, like, you may think it's easy to write a grant until you actually try to write an NSF proposal and realize how many pieces go into it.
Yeah, I totally agree. When we are in a PhD program, we are trying to graduate as soon as possible. There's also pressure to graduate as soon as possible because the funding is not unlimited. But I also wish there was more time, that I spent more time in grad school just so I can develop some of these skills. And I guess a postdoc can address that, but my understanding is that also postdocs are somewhat limited these days as well. So really, you're on your own when you start as a faculty, and it's just a matter of finding the right mentors and surrounding yourself with the right people who can help you develop those skills that perhaps you didn't develop in graduate school or during your postdoc.
Yeah, absolutely. So tell me what you're working on lately. Anything interesting?
I would say, so there's a wide array of projects I'm working on. I don't want to talk about all of them, but see, one of the cooler things I've gotten into are biomimetic adhesives.
Okay.
So during my PhD work, I was looking at what's the durability of bond between these repair materials if you're using the composites and concrete. And we found that they're extremely vulnerable to moisture. So when I started in Delaware, I was like starting to think more about that problem and kind of like start to think about some solutions. And I thought of, mussels. I grew up at the beach. I was always impressed, mussels just like stuck on rocks and it's just so hard to remove them. And I'm like, okay, let me look a little bit more into this. So the more I was learning, the more I realized, yeah, mussels adhesive makes sense for concrete structures for so many different applications. And so I recently, got an NSF grant for this, and that's probably one of the more exciting projects that I'm working on. We're really looking to develop an adhesive that can that's moisture resistant, so that we can have more durable repairs.
Yeah, that's great. I find that so cool. Repair, to me, I'm a sustainability guy. I like to say that I engineer concrete solutions for the next generation of sustainable infrastructure. And repair is so integral to that, because if we can repair the infrastructure we have, if we can retrofit it to be more resilient and more sustainable, then we don't have to rebuild it. And we can save so much in terms of materials and energy and carbon and all those things. I think repair is such a great thing to be studying.
Yeah, totally. I mean, that's definitely one way to address the climate change, right? But I would say repair, in my mind, goes hand in hand with adaptability. If you're not designing structures to be adaptable to, a different use eventually, then repairs can just do so much for us.
Yeah, absolutely.
Tell me more about your projects. What's one of the coolest projects that you're working on?
Yeah, so a lot of my work has been on alternative cements, and I've studied a bunch of them. One of the things we're studying right now is CSA cements, or calcium sulfoaluminates, and they're so interesting because they're more sustainable, they're lower carbon, lower energy than Portland cement, but they also set really fast. So there's some very cool opportunities to integrate them into accelerated construction technology, so we can, kind of limit the impacts of construction on society. And that's all great, but probably the most interesting thing I'm working on right now is I've started studying lunar concrete, which is a concrete material that we make from in situ lunar resources. So NASA has this initiative for developing autonomous construction technologies, because they want to build landing pads and some other infrastructure on the lunar surface as part of their effort to kind of maintain a continued presence there and to continue to study the moon and other planets. So it's obviously not feasible to bring a bunch of concrete materials up to the moon to build this stuff. So we've got to figure out how we can make concrete and concrete infrastructure on the moon with materials that are already there. So I'm working with some folks at Penn State, Alexandra Redlinska, on that project. And it's super exciting to me because, never in all my life did I think as a civil engineer, I'd be working with something that's not strictly tied to the surface of the earth.
I think that's pretty cool. And you're also learning, I guess, a lot about, by learning about these materials, you can learn also, you can probably develop materials that can be applied on Earth as well. They're also
Yeah.
more sustainable, right?
Yeah, absolutely. For example, there's a lot of people studying how we're going to make concrete on Mars eventually, looking way into the future. But Mars, the soil is mostly sulfur. And so those folks are developing new knowledge about sulfur cements, which, we use sometimes in the concrete lab, for capping cylinders and things like that. But learning more about that. When we study the lunar concretes, we're learning how fundamentally how gravity affects the solidification process, and how if we don't have gravity pushing the solids down and closing up the air bubbles, then we get all these large voids, and those large voids are stress concentrators, right? So yeah, you can really learn, even in a very applied project like how do we make concrete on the moon, you can really learn a lot about how materials work in general.
Mm-hmm. Right. So we're both members of ACI, right?
Yeah.
We're pretty active on several committees. So can you talk about how ACI membership has helped your career, professional development, research?
Yeah, I'd love to. To put it quickly, ACI has been incredibly helpful for me. Is it even just chances to promote my research, meeting people that work in the same areas, putting faces to names, these names that you see on these papers that you read, meeting those people, talking to them, asking them questions about their work. I've found funding at ACI, and really just for like network building, which is so important as an academic. I was thinking about this morning, and I was remembering my first ACI convention, which was in Denver, I think in 2015. And my advisor convinced me to submit an abstract, and I was going to go present this work. And I was just terrified, right? I've never been horrible at public speaking, but now I was speaking in public in front of a room full of people who clearly knew way more about what I was talking about than I did. And so I kind of stumbled through my talk, and I don't think I said a word to anybody that didn't speak to me first the whole week. But as I kept going and getting involved in some of the young professional activities and some of the things that Connect does over there, I really feel like I found a place. And 7 years later, I'm a chair of a subcommittee. I'm a secretary of another committee. I'm like leading document development for a third committee, and I've moderated at least like a dozen technical sessions at conferences. And every 6 months, I just look forward to going to the conventions now and seeing people and talking to people and doing the whole networking thing, and really being in this environment where everybody's focused on this thing that I love, which is concrete. And honestly, it's all thanks to ACI and really particularly to the young professional activities, which I think make young professionals feel welcome, give them a voice, give them a way to engage. How about you? Has it been the same for you?
Pretty much the same. So I was going to say, like, I would be literally repeating what you just said to describe my experience. But I guess something else I wanted to touch on, as faculty, I feel like it's really important for us to draw students into ACI, especially those who are interested in concrete. So for me, one thing that ACI enabled was, establishing an ACI chapter at the University of Delaware. They didn't have a chapter before I came. So that was like a really rewarding experience, because I was able to, bring this new student organization to the university. Was able to get students excited about it. And now, Connect told me that this is one of the most active chapters in our region. And I was like, wow, they're making true impact there. So, to me, that was also one exciting thing that ACI enabled as well.
Yeah, that's great. And yeah, you can't understate that, or you can't overstate that, rather. Finding good students is so important to having a good research program. And you get these undergraduates or these master's students that go and present their work, and you get to talk to them and see what their goals are and see where they want to go with life. And sometimes it's a great opportunity to recruit that student, if it's a good fit. I think that's one of the things that I really value about ACI young members is how much they include the students, how much they do for students with the the scholarships and the fellowships and the networking events and all those things, because it is a great way to take students who like I was, who may not be super willing to put themselves out there, and give them a place where they can actually do that and connect with people like us who can hopefully give them good opportunities.
No, for sure. Yeah, I literally agree with everything you're saying right now. Before we wrap up, I guess since this was, we are both academics and the focus was kind of on academia and career paths, I guess, in academia, what would be one piece of advice that you would offer to someone who's maybe just starting out as an academic?
That's a great question. I think the best piece of advice I would give them is to think about how they're going to market themselves, right? So if you want to be an academic, you have to realize that a lot of times there's way more people on the job market than there are jobs. And so if you want to be the one that gets that job, then you need to think carefully about who you are, right? What is your value add? And not only what is your value add, but what is your evidence of that? So we put together these huge application packets. You've got your CV, you've got your personal statement, your research statement, your teaching statement, all these things, right? That's your evidence of who you are as a teacher and as a scholar. And you need to really think about the message you're painting when you market yourself, because I think that's what wins jobs. And I think having good focus and understanding what you're adding to the equation is the number one thing you can do to be successful as a young academic.
Yeah, I totally agree. And one thing I would add to that is also figure out what makes you unique. There's a lot of people doing, testing beams if they're in the structures, or testing columns. And then what is unique about you? What is the unique perspective that you bring to a program? Make sure that you really highlight that and also explain how you fit within the department or within an organization, because really when we are hiring, we want someone who's going to be a good colleague, who's going to be able to collaborate with people, who's going to really be part of the community and not just like a unit of their own. Another thing I wanted to add also is for those who are just starting out, and one thing that I wish I did more of is learn early how to say no to things. Think about what is it that's going to help you the most to get initially tenure, if that's what you're going for, and make a list of those things, and then learn to say no to different opportunities, because there's so many things that you get asked to do, and all of them are great and exciting, but not all of them are going to help you get to where you eventually want to be. So to me, that's advice that I also got. I was not great at saying no. I'm still not good at it, but I would say that's something I would definitely advise.
I think that's great advice, and I'm still working on that one myself.
All right, Robert, it was great chatting with you today.
Yeah, thanks for doing this.
Yeah, thank you all for joining us for Engineering Greatness. It's a monthly podcast series brought to you by ACI.